Hello everyone, welcome to the FreeGen HyperConvergence video demo. Today we're going to focus on performance. What we're going to do is that we're going to use the same piece of hardware. First, we're going to install the Windows 7 on top of the vServer, which is our HyperConvergence solution. And then we're going to install the Windows 7 natively on the same piece of hardware. And then we're going to compare their performance. Okay? So that's basically what we're going to do today. Now let me show you the test bed, the test configuration that we have. What we have here is the 32GB memory, and we have a Xeon E3 CPU, which is 4 core. And now if we go back to the vServer management, this is the Windows 7, only one client installed, and it's a 64-bit. And we are installing on a 50GB volume with the Windows 7. And the Windows 7 right now, they have 16GB memory and using 2 core, which is exactly half of our hardware. So what we have is a 50% we are giving to the FreeGen OS and 50% we are dedicated to this Windows 7 client. For the physical volume perspective, we have 2 SATA HDD 3TB, and we are doing the RAID 1 on it. This is using the LSI RAID controller. We have 1GB memory, 9361 RAID card. Now our 50GB OS volume, the Windows 7, actually is installed on top of this RAID 1 volume. Now we're going to go back to the vServer management page. And what we're going to do is that we're going to start to running the Windows 7. Now we're going to click the FreeGen console. We are using the FreeGen console to manage the Windows 7. Now what we're going to do is that we're going to click the crystal disk mark. This is a standard benchmark. What we're going to do is that, number one, what we're going to do is that we're going to increase the file size to the largest, which is 4,000 megabytes or equivalent to 4 GB. The default iteration is 5. We're going to change it to 2 so we can speed up our testing. With all that, I'm going to start it going. The first row here is a sequential with a big file size. Sequential read right now is starting for the first iteration, and then they're going to go to second iteration. Look at that. The number first come out is the 3,200. And second iteration is 3,254. Both of them are megabyte per second, which is about 10 times the performance of 8 gigabit fiber channel, which in general is about 300 megabyte per second. So your window performance, both read and write, is going to improve by 10 times. Now the next row is going to run, it's going to be the same large file size, but it's going to be random. So the second, third, and the fourth row is all going to be the random access. Since it's the same file size, it's a random. That's why you see the performance is still over 2,000 megabytes per second. And I'm predicting that both read and write, the number is almost going to be the same, about 2,000. So now they're going to the first iteration of the write, and you can see it's close to 2,300. So read and write performance by using FreeGen vServer solution, you're going to have a very similar performance number for both read and write because both are using FreeGen proprietary caching. Now we're starting the last 2 rows, which is a much smaller file size. I believe it's a 4 kilobyte only. You're going to get the random access for the last 2 rows. You get about 43 megabytes per second. And I believe the write is going to come up very, very soon. And the number is going to be very, very similar, close to 40. Yep, you get about 42 megabytes per second. Now the last row is the same small file size, 4 kilobyte, but the queue depth 32, so become more efficient in terms of I/O operation. Now the number is going up to about 135 megabytes per second for read and about 130 for write. So now the test is done. There are 2 reasons that we can achieve such a high performance number. Number one, FreeGen block-based virtual technology Number 2 is the FreeGen proprietary caching algorithm, which is the best in the industry. So the next thing we're going to do is that we're going to now install the Windows 7 on a native machine, and we're going to do exactly the same testing. So stay tuned. Now we have Windows 7 here. We already installed natively in the same machine. It's the same CPU, the Xeon E3 with a 4-core, and with the 32GB memory, a same 64-bit Windows 7. So this is what we are doing right now, is let the window managing all the hardware components instead of FreeGen vServer. So the next thing we're going to do is that we're going to show you that we are using exactly the same LSI RAID controller, 9361 with the 1GB memory. So now we're going to go there right now, go look at the device driver. So you will see that we actually are using the LSI driver. Now this is the D drive. Again, it's a RAID 1, same capacity, 3 TB. And as you can see, Avago, which is the LSI RAID card, the driver is already loaded. So the D drive here is managed by the LSI hardware RAID controller, same RAID controller that we install our Windows 7 as a client. Now we're going to go do the performance test, activated the Crystal Disk Mark. As you can see here, it's the same thing. 4GB capacity and then 2 iteration. Now we're going to click all. So now the testing is going. The expectation is that Windows is not known to be a high performance operating system. So my expectation is that you're going to see the number to be a lot lower than us. Soon we're going to see the information coming out to confirm my belief. So now they're still doing the preparation steps. I want to prepare you guys, when the performance is low, that means the total test time is going to be longer, because it's going to take them a lot longer time to prepare, and also doing the read and write, because the read and write, the data is going to be the same. So if you're going to be slower, that means that the total time to get it done is going to be longer. So the test is going to be a longer test. Now, as you can see here right now, they're still doing the preparation step for the sequential read, which is a 512 kilobyte file size. And now they go ahead and doing the sequential read now, which is on the upper left-hand corner, doing the first iteration. So we should see the number very soon. Okay, the first number coming up is 157 megabytes per second. Wow, this is a very, very low number. I mean that it's a 20 times worse than the vServer with the same piece of hardware. And that's the first iteration. And now the second iteration is ongoing. I believe the number is still going to within about 150 megabytes per second. With this kind of read performance, the expectation is that the write, you're going to see a very, very similar result. That means by choosing the vServer as your virtual technology, you're actually going to pick up 20 times performance improvement by using the same piece of hardware. Now the sequential write started. So the sequential read is finished. We get about 157 megabytes per second. Now we are doing the write cycle. Sequential write, the first iteration is ongoing. The number should show up very, very soon. Now you see it. 153 megabytes per second write. So read and write number, very, very similar. So this is based on Windows managing all the I/O and managing exactly the same hardware configuration. All they can get out from it is about 157 megabytes per second. That's the best that it can do for sequential 512 kilobyte file size. Now they go ahead and do the second row, which, as you all remember, is the same file size, but in this case, it's going to be random. So the number is going to be substantially lower. What you're going to get is only 70 megabytes per second. So it's about half of what you get on the first row. Now the write is ongoing. I believe the write number is going to be very similar to read, which is close to about 70 to 75. Whoa, so this one actually you get a 96 megabyte per second. Now they go for a second iteration. Okay, so both iteration, the write you get 96, read you get 72. So for window write, the write actually the performance is slightly better than the read. Now this is the random number for 4 kilobyte, not even 1 megabyte per second for read. So this is gonna be slow. The write is slightly better, you get about 2 megabyte per second. This is, again, 4 kilobyte size, random. And now we go ahead and do the last row now. This again is the same file size, 4 kilobyte, but it's acute at 32. So get about 2 megabyte per second, read. And now they're gonna do the last 2 iterations, which is gonna be the write. The number is coming. I can promise you for that. You get about 1 megabyte per second. So the last iteration, again, everything is done. If you are interested to experience this 20 times performance improvement, please contact your local sales support.